Hi guys, this is Dr. Kruse, Elementary Statistics. We're going to discuss 5 sampling methods. Now remember, a sample is a subset of the population. So whatever this huge population is that we're measuring, maybe it's all the Black Angus cows in North America, or all the fish in Keystone Lake, or all the college students in the United States. Whatever that huge population is, we don't have time to get to every member of that population, every individual. So what we're going to do is take a subset of that population, a sample, and I just need to make sure that the 30 or 50 or 100 people that I pull out, or cows or fish or whatever I'm measuring, I need to make sure that those 30 or 50 or 100 were picked in a fair way so that they all represent the population. For example, I don't want to, if I'm wondering what maybe the voting preference of Americans is, of United States citizens is, I don't want to just pick like 30 people from my college classroom, all right? Because those people are like 18, 19, 20 years old. They don't really represent the United States of America. They just represent the 18, 19, and 20-year-olds. So they'd be a good sample if my population was all the 18, 19, and 20-year-olds, but they'd be a bad sample if my population was, United States citizens of all ages. So we have to come up with a fair method for creating a sample that is representative of that larger population. We have 5 methods we're going to discuss today. So the first one's the easiest. It's just drawing names out of a hat. You guys have all done this. It's called simple random sampling, and every individual has an equal chance of being picked. So if I'm giving away a calculator or something like that, I would have every student in my classroom put their name in a hat. I'd shake up all the names, and I'd have someone, blindly pull a name out of the hat, and that person is the winner. They win the calculator. But every individual in the room had an equal chance of being picked. If there was 30 people in the room, everybody had a 1 out of 30 chance of being picked. So it's very, very fair. It's a very fair method of creating a sample. Just pull names out of a hat, all right? If I wanted a group of 10 random students out of my 30 in the classroom, I'd put all 30 names in the hat, and I'd randomly shake the hat and draw out 10 names. And I would have a good sample, a simple random sample. There's something you can use. It's also called a random number generator or a random number table. A random number generator is in computer programs like Excel. Excel uses them. There's a function in Excel. If you're working on a worksheet, you can say, hey, just generate a random number between 1 and 75, for example, and you hit enter, and it will give you, 37 or 45 or 74. It'll just randomly pick a number between the two numbers you gave it, between those two parameters that you set. So you can draw names out of a hat, or you can use a computer method like a random number generator to create a fair random sample, simple random sampling. That one's pretty easy to understand. The next two are a little confusing, so I'm going to spend a little time on them. It's stratified and cluster sampling. All right, now the way I remember it, let me just start with this, is I remember stratified starts with an S, and I remember this method picks some individuals from all of the groups. It'll make sense in a minute. I'm going to interview some people from all groups, versus cluster sampling, which interviews all people but only from some of the groups. All right, let me go over it one more time. So stratified sampling, imagine a classroom. Let's say I have 16 students in my classroom, and I have 4 in this corner, and 4 in this corner, and 4 in this corner, and 4 in this corner. So maybe I just assign them the names 1, 2, 3, 4, and I do that for each corner. So I have 16 students in 4 sections, all right? Now if I'm going to draw a sample from these students, maybe I have a 30-minute interview that I have to administer to these students one at a time. Well, I don't have time to do that for 16 students, so I'm going to create a sample. I'm going to gather a sample that's representative of this classroom, and I want to do it in a fair way. If I'm using the stratified method, I'm going to pull some from each of these groups. Maybe I want to pull 2 members from each group, so I want 2 of these guys, and 2 of these, and 2 of these, and 2 of these. So that would give me a group of 8. Maybe I have time to interview 8 students. So how do I pick the 2? Well, that goes back to simple random sampling. So I'm going to start over here in the top left corner, these 4 students over here, and I'm going to put each of their names in a hat. All right, maybe they're just the names 1, 2, 3, 4, and I shake up the hat and I draw, let's say I draw twice because I want to pull 2 from each corner. And maybe I draw the numbers 1 and 4. Okay, so those are the 2 students I'm going to interview from this group. I'm interviewing some of the students from that group, and I'm going to do that for each of the groups. So over here, I'm going to name them 1, 2, 3, 4, and I'm going to go into the hat again and pull 2 numbers, and maybe I pull the numbers 1 and 2. So I'm going to interview those 2 students. And I do it again over here, and maybe I draw the numbers 2 and 3. And over here, maybe I draw the numbers 3 and 4. So now I have randomly picked, using the stratified method of sampling, I have randomly picked 8 students to interview. I picked some students from all of the groups. I picked 2 from here, 2 from here, 2 from here, and 2 from here. I picked some of the students from all of the groups. Okay? I'll come back to the rest of this in a minute. Versus cluster sampling. It's kind of doing the same thing, but in a different method. Okay, cluster sampling, I'm looking at my classroom and I'm going, dang, 16 students, and these are 30-minute interviews. I don't have time to do all 16 students. You know what I'm going to do? I got these guys broken into 4 groups. I'm just going to interview a couple of those groups. So maybe this group over here, this is group 1, and maybe this is group 2 in this corner, and maybe this is group 3 in this corner, and this is group 4 in this corner. Okay, you know what I'm going to do? I'm going to put 1, 2, 3, and 4 into a hat. Simple random sampling. I'm going to put 1, 2, 3, and 4 into a hat. I'm going to shake up the hat, and I'm going to randomly draw 2 numbers. And, maybe I draw out the number 2 and 4. Maybe those are the 2 numbers I draw out of the hat. Well, I'm going to go over here to group 2, and I'm going to interview everybody. I'm going to interview all 4 of those people in group 2. And then I'm going to go to group 4, and I'm going to interview everybody, all 4 people in group 4. I'm still interviewing 8 people. All right, I just did it in a different way. So I randomly selected 2 groups, and I'm going to interview everybody in some of the groups. See, I didn't even interview anybody in these 2 groups. With cluster sampling, I'm going to interview everybody in this group and everybody in this group, but I didn't get all the groups. So I interviewed everybody from some of the groups versus a few people from all of the groups. So that's how I write it. I interview some from all of the groups, or I interview everybody, but just from some of the groups. That's stratified versus cluster. Some other notes on stratified is, strata. The word strata means layer. If you've taken like geology or geography, it's like layers of the earth, strata. All right, if we use layers, like at college, there's freshmen, sophomore, juniors, and seniors. Those are different layers of students. But I don't have time to interview, all 20,000 students at the university. Maybe I have time to do 100 freshmen, 100 sophomores, 100 juniors, and 100 seniors. Well, that's some from all of the layers. That's some from all of the strata. 100 students from each layer, all right? So some from all. That's stratified. You can also use time zones as well, all right? And clusters, lots of times you might see the word geographic with cluster sampling. Lots of times they use geographic breakdowns, things that already exist, all right, like counties, schools, states. Those lines are already drawn out for you. So, for example, we live in Oklahoma, so there's, about 50 counties in Oklahoma. Well, I don't have time to go to all 50 counties and, find an average weight of Black Angus cows in 50 counties. Maybe I have time to go to 5 counties, all right? So I would randomly pick, I'd put all 50 of those counties in a hat, and I would shake it up and make it all random, and I would pull out 5 counties, and I would go and weigh all of the Black Angus cows in those 5 counties that I randomly picked. If I weigh all of the cows in 5 counties, I have a good cluster sample. I couldn't go to all the counties, so I randomly picked 5, and I weighed all the cows in those 5 counties. Same thing with schools. Here we have 6 elementary schools. I don't have time to interview, say, all the teachers at 6 schools, Maybe I have time to go to 3 schools. So I'll number the schools 1, 2, 3, 4, 5, 6. I'll put 6 numbers in a hat, I'll shake it up, and I'll randomly draw 3 numbers. And maybe I draw the numbers 2, 3, and 6. So I'll go to school 2, school 3, and school 6, and I'll interview all the teachers from those schools. I didn't go to all the schools. I just went to some of the schools, but I interviewed everybody. All right, systematic, probably the easiest one to pick out. Systematic just means you have a system, like you're going to pick every 50th name or interview every 30th person or weigh every third cow that goes through the chute, or maybe you're just going to keep every 4th fish out of the lake. So as long as you see any kind of system, that's pretty easy to spot. Now, what we have to remember with systematic sampling, we have to give everybody a fair chance of winning. You remember that? So no matter what method we make, we have to create a method or use a method that gives everybody a fair chance of winning. For example, in the phone book has everybody's name listed alphabetically, A, B, C, all the way up to Z. Well, how do I know where to start in the phone book? Because I want to give everybody a fair chance of being interviewed. Well, we put all those letters in a hat, for example, A, B, C, all the way up to Z, that's 26 letters. Put all 26 letters in the hat, shake it up, and pull out one of those letters. And maybe we pull out the letter R, all right? Well, that's going to be our starting point. To find that starting point, you have to use simple random sampling. So we use simple random sampling. We randomly selected R as the starting point. And after that, we picked every 50th name and called them for an interview or a survey or something. Or it could be every 30th name or every 100th name. It's whatever number you pick here. But you got to make sure you start at a random place. That gives everybody a fair chance of winning. And then finally, convenience sampling, which is probably the worst method of sampling. You just grab people who are convenient. Now, people do this all the time, but it's not a great sample. Maybe I just reach out in the hall when I'm teaching class and I just grab the next 30 people that walk by and I survey them or I measure them or I ask them a question or whatever I'm going to study about these people. Well, I mean, that is a method, and it definitely is easy. It's convenient, but does it really represent, what you're looking for? It kind of depends on what your population is. If your population is voters in the United States and you want to know their opinions of the president, well, if I just grab the next 30 college people that walk by, since I'm in college and I'm a college professor and that's who's walking by my door, if I grab the next 30 people that walk by and I ask them their opinion of the president, that's not going to be a good representation of my population, because my population is everybody that can vote, everybody that's 18 years or older, all the way up to 80, 90, 100 years old. All those people can vote. So if I'm just asking 18, 19, and 20-year-olds, well, that's not really a good sample. It doesn't represent my population of people that can vote. So convenience sampling often grabs a group who are convenient, but not a good sample for your population. So not a great sampling method. But that's it for today. There's your 5 sampling methods.